going to do lesson 2.5 practice. That's all we're going to do. You've already read the lesson and worked out some of the problems already in it. Let's practice together to make sure we have a good understanding of this lesson. So that's the title for your page. We're just doing lesson 2.5 practice problems, okay? So number 1, write down the following inequality and we will solve this and graph our solution. Okay, is there only one way to start solving this one? What do you think? There's only one way, one right way, and everybody should be doing it that way? What do you think? Justin?
Isn't there like 2 that I can see?
There's at least 2. And what's one of the ways we could go about solving this? What would be our first move? Justin?
Subtract 4x on both sides.
Okay, we can subtract 4x from both sides. And what's our reason for subtracting 4x? Justin?
Because then there would only be one number on each side.
There'd only be one
Variable.
term on each side. Yeah, we only have a variable term, on one side instead of on both sides. We need to eliminate them on one side or the other, get them collected to the same, to be on one side only. So we can subtract 4x from both sides. What's another thing we could do? Russell?
Subtract 3x.
We can subtract 3x from both sides. What's another thing we could do? Doesn't mean it necessarily has to be the first move, but it could be a first move, Russell.
You could possibly subtract 7.
Yeah, you can subtract 7 from both sides if you wanted to. Anything else? Would this be a good one to start by dividing?
No.
No. Why not? Why not? Why wouldn't this be a good one to start dividing?
Because 4 can't go into 3
4 can't go into 3
with a good number.
with a nice number. So in other words, is there anything that would all 3 terms would be divisible by nicely? All 3 of them would be?
1.
Well, divide by 1. Would that get us anywhere? Yeah, we could divide by 1. We could use some more lead. Okay, but so let's do Justin's way. He said let's subtract 4x from both sides. We have lots of options, but we'll go with Justin's way. We have 7 left on the left side then, because the goal was to eliminate them on that side. What do we have on the right side? Negative 1x, or just a negative x. Do they mean the same thing? Negative 1x, negative x. Okay, what's our next move? Need you to be doing this with me. You already got to call the first move. What's the next move? Tamara? Divide by negative 1 on both sides. Okay, so we divide both sides by negative 1. And Russell?
Reverse the symbols.
And reverse the symbol in our next step, right? Okay, so what is 7 divided by negative 1?
Negative 7.
Negative 7. And we have to reverse the symbol? Why?
Because you divide by a negative.
Because we divided by a negative, and now we have x, okay? So we have to graph that. Go ahead and graph it. What's the graph look like for that solution? Did I graph it correctly? No? Yeah?
Yes.
Some say no, some say yeah. What does the inequality say right now, the way it's sitting just like this? What does that solution say? What's that telling us? Becca? X is greater than or equal to negative 7. Because I could also write this as, I could switch it around and flip the sign again and write it with the variable on the left side, and then maybe it's easier to understand, correct? But when it's like this, what does it say?
Negative 7 is less than or equal to
Yeah, negative 7 is less than or equal to x. What is x?
Any number greater than
Anything in our shaded region? Is that really x?
all real numbers greater than or equal to -7.
Yeah. But this really says negative 7 is less than or equal to x. I want to know what x is
All real
on our
numbers.
graph. Well, I know. So in other words, negative 7 has to be less than all the shaded region, doesn't it? Does not the shaded region represent our solutions? Does it not represent x? Did you not realize that when you were shading, you're showing all the things x can be? So this says negative 7 has to be less than or equal to, the equal to is the shaded circle, equal to all the shaded region. Is negative 7 less than all of our shaded region? Yeah. Okay. So I get what you were trying to say to me, but I'm also trying to get you to be able to reason out what does it mean when the variable's not on the left side? What does it look like? Okay? Okay, let's do another one. Here's your next one. I want you to solve the following inequality. Today's goal is to be able to solve inequalities in one variable with variable terms on both sides. So every single one we do today will have variable terms on both sides. What's a good first move for this? Distributive property. In other words, is distributive property solving? What do you think? Is distributive property solving? No, it's called simplifying. Okay, so it's called simplifying. So we really need to simplify this by doing distributive property first to get rid of those parentheses. Now, we could divide first if we could come up with a number that would be good to divide by. Is there something that goes into 4 that also goes into 5? That would, other than 1, that would be nice. So we are going to, probably the best thing to do is the distributive property first. And then take it from there, right? Okay, go ahead and solve that. Let's see if we all get the same solution. You done, Nick?
Yeah.
Okay, come on up and do it for me. I'm feeling kind of tired. I don't want to do it. Yes, Kelly?
Do you want us to graph it?
And I want you to graph your solution. And it works better with your fingertip because that, if you use the pen, it tends to start doing dash lines. I don't know why.
Can I have your attention? If you have any recycling, please set it outside your door at this time. If you didn't get it out the first time, you have one more chance. Please set your recycling out in the hallway now. Thank you.
There's some old lady outside my door. You never see. Okay, so do we agree with Nick?
Yes.
Yeah. He kind of likes to have both of his first steps of work in the same line, you know, because there's a shortage of paper nowadays or something.
I just like to keep it all on the page.
You just like to keep it all on the page. Oh,
Yeah.
I see. Okay, so you added. Can I go with that? You added 4x to both sides first. Was that your
Yeah.
first move? Okay.
Yeah.
And then after you did that, then you decided that you should, because the x's were now on the right side, we should get rid of the constant on the right side and add 10 to both sides. And then we would have the x's by themselves and the constant by itself. Okay. So does that have to be the first move, adding 4x?
No.
Anybody subtract 5x from both sides instead? You all use the same first move Nick did?
That's all.
It is easier. Why is it easier?
Because
then you don't have to deal with negatives, that's right, so, okay. Now, the only thing that I don't really like is a little bit, and I think it's just because he was working at the smart board. What's wrong with Nick's number line?
Well,
Justin,
The graph,
the graph, what's wrong with the graph?
2 is closer to 3,
Then,
1 is as close to 2.
oh yeah, they're really equal distance. 1 and 3 are really supposed to be equal distance from 2, correct? Yeah, so if we have a good number line, it's, it's pretty close to being, but, it looks more like there's 1 unit between 1 and 2, and how much of a unit between 2 and 3?
Half or 1, 4, 5.
About 3/4.
Yeah, that's what I meant to say.
That's what I thought you meant. Okay, so anybody have any questions about this one? Okay, then let's try another one. See what you learned in your SQ3Rs. Solve the following. It's kind of a long ways away from there. I'm going to put it a little bit closer so you aren't confused. X minus 1. Okay, this is a -3 out front here. So all kinds of first moves you can make with this one. Well, I shouldn't say all kinds. A few. What are you doing? What first move are you making? Are you starting to solve it right away, or are you going to simplify it first? Simplify. You're going to do distributive property? Oh, okay. Well, then let's make sure we do the distributive property correctly, because this does not always go so well for everybody. Look and see, do you have the next following statement? If you did distributive property? Because why does it end up +3? Russell?
basically a -1.
This is basically a -1. If I change it to add the opposite, it's a -1. That -3 is getting multiplied by. Now, tell me something else. Because we multiplied by a negative number over here, does that mean the sign should change?
No.
Why not? I thought when you multiplied by a negative, when you have an inequality, you were supposed to reverse the inequality symbol. Now you're going to try and teach us differently?
Not yet.
Yeah, now we're confused. Seriously, should we reverse that? Because we multiplied by a negative.
But
It wasn't on the other side.
Well, so what? Did I say which side it had to be on?
and
I
we
thought the rule was if you
we
multiply or divide by a negative number, you have to reverse
were
the symbol.
just
It's just divide by.
No, it's multiply too.
we're
What
just
does it?
simplifying.
We're just simplifying. That's when you're what?
Just breaking it down into easier.
That's when you're what? Solving. Are we solving yet? Okay, so we have to make sure we understand that we were simplifying. That's why we don't reverse the symbol here. Okay, so have you already solved this? Have you done?
Okay.
Oh, go ahead and finish because I kind of distracted you, didn't I? Russell,
I solved it.
you solved it? You want to come finish mine then? Thanks.
Thanks. That is up there.
Okay, thank you. What happened?
Well, we took away 3 from 3, so there was just nothing. We just lost it.
We lost what? What's it?
The thing.
Justin?
We lost our variable.
We lost our variable.
Yeah, that.
Oh, we lost our variable terms. They eliminated, they disappeared, Michaela?
Okay, I got a different answer.
Okay, what'd you get?
I subtracted the 3 from the 6 right away. And then I got 3 minus 3x is less than negative 3x. And then I added 3x to both sides and I got 3 is less than 0.
So I'm doing Michaela's in the blue. Did I keep up so far?
Yeah,
Okay, and then the next thing you did is you what?
added 3x both sides.
And then you added 3x to both sides, and when you added 3x to both sides, you got what statement?
3 is less than 0.
Okay,
So then I still got no.
but you still say it's no solution. So how are we gonna know, I mean, can we come up with different statements in the end?
Yeah.
Sure we can. Russell?
That says 0 is greater than 3.
Right.
Yeah, so it's.
And it says 3 is less than 0. Right? So, here's the deal. Russell, yours says 3 is greater than 6. Do you like that any better? Is that any better? Is that true? Is this statement false, the red one?
Yes.
Yeah, this is false. 6 is not less than 3. 3 is not greater than 6. Is this true or false?
False.
This is false. 3 is not less than 0. 0 is not greater than 3. Either way, the variables eliminate and you end up with a false statement. What does that tell us in equations? It tells us the same thing in inequalities. There is no solution. Okay? So as long as you end up with your work legitimately gets you to something that makes sense, it's okay that you have something different because you might take a different process to get to where we end up. Okay? So it's okay in these. The main thing is we all better have the variables eliminated or something went wrong. And we all better end up with a false statement or something went wrong. And our false statement better come from good work that supports it. Okay? Okay, let's try another one. Your next one, fairly short. Oh, by the way, how come we didn't graph the last one?
Oops. But oh, there's a
There's nothing to graph, right? There's no solution. We'd have an empty number line. We'd make this number line for nothing. There wouldn't be anything we could shade on it because there was no solution. So we don't have to graph no solution. Just in case it happens, I just want to save you some work. Who wants to do it for us this time? Somebody who hasn't been up there, come on, go. For some reason I went on strike, I'm not working anymore. I've already put in my 70 hours this week. I'm done.
Okay. Can I do one part that I know for sure is right?
If I wouldn't have taken Tuesday off, chances are I would have already, but no, yes. I typically work 60 to 80 hours every week. Okay, who wants to do this? Come on, seriously. You don't even feel sorry for me. I cannot believe it. Because I took Tuesday off? Is that a lie?
No.
Do it again.
Fine.
No.
I'll show
Wow,
you guys how
guys.
to do it.
If I'm ready, I can finish it.
Okay, come on.
Oh, Coach Austin.
Go, yeah,
I'm
really.
not sure it's right. I mean, I'm not
Oh,
sure.
thanks, Justin.
Are you even tall enough for this?
I think so. I'm not right now, but I think you are. Oh, you just want a different color? Well, then
Oh, this thing is weird. Oh, I like it. Oh. Well, let's just say I did this one first. Okay, I'm making more floors than I need to.
-40.
Okay. You only worked 40 hours this week, huh?
Yeah. That should be a 0.
Okay.
Oh,
It's all right. Keep going. Don't let their laughter, intimidate you. You're getting paid big bucks for this.
Good job.
Huh.
oh no, Russell's gonna prove
Oh,
me.
Russell's got an issue apparently. Oh, and so does Kelly. Oh no, I think it's got something to do with they have costumes on today. That must be why.
You should call on me because Russell's been talking all day.
Yeah, okay, I'll call on you, Kelly. Who are you, by
Smarter
the
than
way?
Kelly.
I'm Allison Wonder.
Okay, Alice, could you tell us what the problem is here?
He shouldn't put -4, he should have put, oh, just kidding.
Oh,
I did that wrong.
Okay, well, thanks for admitting that, Alice. That's awesome. Okay. Anybody else? Other than Russell? Who are you, Russell?
Like gangster.
You're a gangster.
Mafia.
Oh,
One of
okay.
those
Gang.
Russell, what is the problem?
He put no solution when it should be all real numbers.
Why should it be all real numbers, Russell?
Because any number times for any number can be substituted in for x, so
How do you know?
Yeah.
Are gangsters smarter than the rest of us or what? Okay, holy shit. This is serious stuff. Yeah, whatever color you want, buddy. We're not.
You can
we're not
erase
messing
it,
with
you
you.
can
Who wants this tonight?
Can erase my smiley face.
I think he
Oh,
just
he's
wanted
so Russell, if you need to, you can erase that. I think you want. Just go.
Yeah, Russell's pretty smart. He must be doing good.
No, you didn't. Keep
That's what I
going.
meant to say.
Keep going. Trust me. You know what you're doing. I don't. Well, I thought for a little bit you did.
So does that mean we're
Russell,
all
let's
wrong?
extend
page.
Hey, don't lose the equal to bar. Okay, there we go. Okay. So, what are you proving to them right now? Tell them what you're proving to them. Because Jocelyn said it's no solution, and you're saying what?
-4 could be less than.
Well, what are you proving with that? I don't. So yes, -4 is less than or equal to 0. So what?
Any number can be substituted in for x and it'll still be kind of a true statement.
It'll still make it true. Oh, so which one did you just prove is true? What value?
That -4 is
No,
less
which
than
value did you just prove from the number line makes it true?
1.
1. Okay.
That's cheating.
Well, then he just disproved it's no solution because he's already found one solution. Sorry.
But they're gonna get like 3 is in number 3 to get
I'm right.
3 is I think less than 0 and still no solution.
Yeah, but 3 is less than 0. Is that true?
No.
So if we go back to that, should we just try, should we try the gangsters number? It worked for that last one, so should we try it for that? Oh gosh, this thing's making me sick. Okay, so 1, let's put 1 in there and let's try his number for that. 2 take away 1 is? 1. 1 times 3 is?
3.
3, okay. 1 plus -1 is?
0.
0, so we'd have -3 times 0, that's? 0, so we're gonna have 3 is less than 0. Oh, we got that one now. True or false? Okay, so 1 doesn't make that one true. Okay, so remember here we ended up with false statements after the variable eliminated, so we said there's no solution. No matter how many different values we would try for x in number 3, we would not find a value ever that would make that true. A positive number, 0 itself, a negative number, it would not matter. But Russell just proved that, well, he already found one. He found that 1 works. Do you think there are any other numbers that work?
Yeah.
Well, what numbers work then?
2, 4, 6, 8.
Maybe the
All real
How about
numbers.
negatives?
Yes.
Well, let's try one. Pick a negative number for me.
27 negative.
Negative 27.
Negative 10.
We should be a little bit more reasonable. Okay, negative 10, I like that one a little better. Negative 10, take away 1.
-4.
Negative 11. Negative 11 times 4.
Negative 44.
That's negative 44, okay. Negative 10 times 4. Negative 40. Okay, so negative 40, is negative 44 less than or equal to negative 40?
Yes.
Is that true?
Yes.
Well, then negative number work too. So we got 1 to work now so far, we got negative 10 to work.
Oh.
Or
Jeez.
equal to, yeah.
Okay, I thought though.
So guess what? This is just like equations. When the variables eliminate and you end up with, is this a true or a false statement? True. Isn't negative 4 less than or equal to 0?
Yeah, I got a little.
So this is true. So if it's true, that doesn't mean no solution. It means
All real numbers.
all real numbers. Yeah, this is and we should have had some like this in our notes we took on our own.
Justin, did you take the notes?
No. Thing was that I thought negative 4 was a 4, not with the negative, so I just saw 4.
Then why'd you write a negative?
Listen, I saw 4
Okay.
and a 0, and I was just automatically, well, 4 is bigger than 0, duh, and then
Yeah.
negatives just.
Okay, let's go. One more. Write down the following word statement. For more than twice a number. So write down this word statement first of all. Is greater than 2/3 the number.
Great. Do we write that? Or
Maybe you're writing this down. 2/3 of the number, we'll say. So write that word statement.
like write down?
Well, I want you to write down the word statement first, and then I do want you to replace that with an algebraic statement.
Okay.
For keywords in there that'll help you decide what can those words be replaced with. Okay, who wants to give me an algebraic statement for this? Justin, would you make up your mind?
Oh.
Russell?
4 plus 2x is greater than 2/3 times x.
Oh, I should have done. I should.
Okay, how many of you agree? Okay. Why is that not an inequality symbol more than?
Because there are no is.
There is not an is there. If it said 4 is more than, would that be an inequality symbol? Yeah, then it would have been. Not that we could not necessarily want both two inequality symbols in here, but the word is missing. So that is your clue right there that that one means addition. Okay. This one, because it does have the is in it, says this is our inequality symbol. Okay. Now this is one of those that has a fraction in it. So I'm going to suggest that life would be a whole lot easier if we could just get rid of that fraction right away. How could we get rid of the fraction right away? Justin? Times it.
Right, reciprocal.
Right, it's reciprocal. Oh, that's way too much work. I don't want to work that hard. Come on, let me, remember it's Fridays. Try again, Justin.
Subtract 2x.
No, that's too much work. Caleb?
We need a common denominator.
You couldn't get a common denominator, but I'm thinking I don't even want to work that hard. Kelly?
What if you change it into a decimal?
I don't want to do a decimal because 2/3 isn't a nice decimal. Justin?
Let's just not do it.
Let's do it. Russell?
Multiply all numbers by 3.
Thank you.
That's what.
That's what you were going to say. I don't know why you guys just can't say it.
Oh, okay, I just don't like being wrong.
Well, you,
That's
okay. In other words, that there's only one denominator in this problem and it's a 3. Just multiply every piece by that denominator and it'll be gone. So, again, there should have been a problem like that in your SQ3R. 12 plus 6x is greater than what?
2x.
Yeah, these 3's cancel each other out. And we have a 2x over here.
oh, I can have the X.
Okay. So find the solution for that and graph it. Holy cow, now even my fingers doing dashed. This is good. What did I do here? Figure out what switched it to a not solid line here.
Oh, go right by that square thing. To the right of that now.
Looks like it's on a solid line, so, okay, we'll just keep trying here. So we have a 4x is greater than negative, it's shaped up now. No, not still correct. Oops. Okay, now you probably didn't take the same process I did you? But I wanted you to see, and I think Luke did one like this also, because some of us don't know what to do. We just get lost somehow along the way. If we take it away over here, we're like, oh, there's nothing left there anymore, I just leave it blank. When there's nothing left, we put a 0, don't we? Okay, tell me what the graph of this looks like. Open circle, F,
Going to the right.
-3 going to the
Right.
right, okay. Okay, you need to finish up your anticipation reaction guide now. So let's look over at the other side.